Okay. Good afternoon. Am I audible? Someone please reply me if I'm audible.
Yes, sir.
Yes, we will continue our discussion on areas. Okay, we were discussing about the general methods of determining the areas. I think the same list is still there on the board. Okay, by computations directly based on the field measurement, by computations based on the measurement from a map. Okay, and then by mechanical means, that is using some instruments, uh, using some instruments to calculate the area. So these are so now we discuss one by one these general methods. Okay. So first, we'll go with the computation based directly based on the field measurement. Here again, there are different techniques what we may have to adopt. Okay. So we'll go with this technique now. Among them, the first one is divide the area into a set of triangles. Dividing the area into
Sir, speak a bit loudly.
first we need to divide. First method is dividing the area into a set of triangles. Okay, so we all know that how to calculate the area of a triangle if we know the size of the triangle. So what is to be done here is we are supposed to divide the area into a set of triangles, maybe like this. If this is your topography, then what you can do is select one center point, then try to have your survey stations in sine survey. Okay, in sine survey we deal basically with linear measurement. Okay, now these are your set of triangles which represent the given topography. And now can note down the sides of all the triangles, then calculate the areas of individual triangles, then sum up all the the method is not the method is not so exact method because it all depends on how accurately we are dealing on the survey. At the same time, it all depends on how our mean survey lines are. Now, if you could look at this portion only, this is my boundary, but this is my main survey line. So this area is being not included in the computations. It happens sometimes. Okay, so that's why these methods are not the exact methods, they are the estimates. What we call them as estimates. We are going to estimate the area in the volume. So dividing the area into a set of triangles, that's the first part. And the second part is by offsets to the baseline. By offsets to the baseline. Again, this method depends on the nature of a topography. If your topography is like strip, if your topography is like a strip, okay, then what we will do is we divide. We will run a baseline parallel to a parallel to a boundary. Then at regular intervals of distances, we note down the perpendicular offsets. Okay, so this distance will be known, this will be known, so it may act as either a rectangle or a trapezoidal. Then we have to calculate the individual areas of these rectangles or the trapezoidals, and then we need to sum up to get my final area. Okay, so this is baseline here, and these are called as offsets. These are called as offsets. Okay. Generally, we go with the perpendicular offsets. And another method is if we could know latitude and departure, we know how to calculate latitude and departure. With latitude and departure, we will get the coordinates also. Okay. So first thing is by latitudes and departures. By latitudes and departures. Okay, and last one by coordinates. If we know xy position of each and every points in the topography, then how to calculate the area. Okay, so these are the few methods. Now we'll go with this method by offsets to the baseline or from the baseline. Okay, so take the heading as areas from offsets to a baseline. Areas from offsets to a baseline. Areas from offsets to a baseline. So there are different rules to be followed here. Rules indicate the different formulae actually. Okay, so there are different formulae to be understood. Then we need to adopt those techniques to calculate the area. Okay, so first I list the different rules which are being adopted here. First one is the ordinate rule. Second one is average ordinate rule. Third one is trapezoidal rule. Third one is trapezoidal rule. And the fourth one is Simpson's one-third rule. I don't know if you have studied these rules in engineering mathematics also. Maybe you might be studying this semester or you might have studied or I don't know. I don't remember English semester if you read it, but they are also part of engineering mathematics. Okay, so these are the four rules to be understood in areas from office to a baseline. And what happens is the first three rules, they make an assumption that boundaries are joined with straight lines. Boundaries are joined with straight line. That is an assumption for the first three rules. For the first three rules, the assumption is boundaries are joined with a straight line, whereas for the Simpson's one-third rule, the assumption is boundaries are joined with parabola. Boundaries are joined with a parabola. Okay. So boundary between alternating offsets. It's parabola between alternating offsets. Okay, so these are the assumptions which have been used to derive the expressions for all these four. Okay, so we'll study one by one. So we take the heading first as mid-ordinate rule. We do it first mid-ordinate rule. So what's the assumption in the mid-ordinate rule again? Assumption in mid-ordinate rule is the boundaries are being joined by straight lines between the offsets or between the ordinates. Here, so we'll try to, now the area is being divided into a set of strips. The total area is being divided into a set of strips. Okay, so that starts from, this is my first strip, second strip, this becomes a first strip, first offset, second offset, third offset, fourth offset. Like this, there will be n number of offsets. Okay, each strip is of equal width d. Each strip is of equal width d. Each strip is of equal width d. What is being done here is we divide the area into segments. Basically, we divide the area into segments of equal width. They can be called as segments or strips. Some textbooks use strips, some textbooks use segments. They can be used synonymously, not an issue. Okay, there will be n number of segments to cover my total area. And this is the total length. I'm taking L as total length. Okay, I'm taking L as total length. Now my assumption is boundaries are joined with a straight line. So it's something like this. Boundaries are joined with straight lines. That's an assumption. Okay. Now in the mid-ordinate rule, what do? We we measure the ordinate at the center portion of the strip. We measure the ordinate at the center portion of the strip. That is, if this is my first strip, then I measure the ordinate at the center portion. This I will call it as H1. Similarly, for second strip, this is my mid-ordinate. Ordinates at the midpoint, they are mid-ordinates. Similarly here, this is the mid-ordinate for the third strip. And this is going to be a mid-ordinate for the nth number of strip. Okay. See, I'll call this as H1. Mid-ordinate for strip 1. This is H2. Mid-ordinate for strip 2. This is H3. Mid-ordinate for strip 3. Similarly, this is nth strip, so it is Hn. It is Hn. Okay. Can you tell me what is L equals to in this case? Each segments are of equal length d. So your total length will be L is equals to n into d. I have 10 segments. If d is 5 meter, then my total L will be 50 meter in that way. Okay. The total length is n into d. Total length is n into d. Okay. Any difficulties in the sketch? Please let me know. Yes, any difficulties in the sketch? Okay, now if you don't have any difficulty, we'll proceed. Here, your total area covered between the baseline and first offset, second offset, and then the boundaries. Your total area is equals to, can you see this portion of the board? Yes. I'll use this. In the mid-ordinate rule, your area is equals to average of mid-ordinates multiplied by length of the baseline. It's average of mid-ordinates multiplied by length of baseline. Okay. What is average? What is average of mid-ordinates? It's going to be equals to sum of all the mid-ordinates h1 plus h2 plus h3 up to hn divided by number of mid-ordinates. How many numbers we have? Yes, up to hn we have the mid-ordinates. Then what is the total number of mid-ordinates? If I have only 3 segments, then the number of mid-ordinates is 1, 2, 3. If I have 4 segments, then the number of mid-ordinates will be 1, 2, 3, 4. If I have n number of segments, then the number of mid-ordinates will be n. So, average of mid-ordinates is sum of all the h divided by n multiplied by n multiplied by n. Okay, this is one formula what you have to remember. It can also be simplified. This can also be simplified by mentioning in this way. It's sum of h divided by n. Now your L is equals to n into d. Please remember, your L is equals to n into d. So finally your area can be written as d into sum of all the h. This is the formula for the area from mid-ordinates rule. From mid-ordinates rule. So please keep this equation in a box. Area from mid-ordinates rule is equals to d into sum of h. D into sum of h will give it area from the mid-ordinates rule. Any difficulty? We'll go with the second rule then. If you don't speak, I assume you don't have any difficulties. Okay, and second rule is average ordinate rule. Okay, it is not mid-ordinate, it is average ordinate rule. This is something different. Please draw the sketch without showing the mid-ordinates. Okay, now here, what is being done here? We don't take the mid-ordinate, instead, we take the ordinates or the offsets at the start and end point of a strip. Okay, this is my first strip, and the start of the strip, offset at the start of the strip is this one, so I'm going to call it as O0. My O0 is the offset at the start of the strip. This offset I'm going to call it as O1. This I'm going to call it as O2. This as O3. Okay, like this. Here we will have On and this will be On minus 1. On and On minus 1. Okay, and in this case, your area, in this case, your area is equals to average of ordinates multiplied by length. In this case, your area is equals to average of ordinates multiplied by length. Okay, area is average of ordinates multiplied by length. Then how to calculate the average of ordinates? If you can help me out here. What is average of ordinates? It's sum of all the ordinates divided by number of ordinates. What do you mean by average? Sum of all the parameters divided by the number, isn't it? Now, if I want to have average of ordinates, then what I have to do? I'm supposed to calculate first sum of all the ordinates. So it is O0 plus O1 plus O2 up to On divided by what? Yes, divided by what?
Then
Please cross verify it. Is it going to be just n here? Remember, I am starting with O0. Let me take only three offsets here. Let me take only three offsets. O0, O1 and O2. Okay, then what will be our average?
3, sir.
Forget about this portion. Forget about this portion. You consider only three offsets. Then what is going to be average?
3, sir.
Why?
Three offsets.
See, you just don't give me the number in the denominator. It is your average is going to be O0 plus O1 plus O2 divided by what?
3.
Divided by 3. Okay, good. What if you have four number of ordinates? Like up to O3 you have. Forget about this portion now. Up to O3 you have, then what is the average of the ordinates?
O1 plus O2 plus O2 plus O3 divided by 4.
Divided by 4. Very good. Okay, when it ends with O3, you are going with divided by 4. Please remember. When it ended with O2, you went divided by 3. Okay, now you have offsets up to n. Then what will be there in the denominator now?
N plus 1.
Okay, it's n plus 1. Right. It's n plus 1 multiplied by length. Okay, it can be written as like sum of all the offsets divided by n plus 1 multiplied by n. Okay, this is the formula for calculating the area by average ordinate rule. This is the formula for calculating the area by average ordinate rule. Okay, any difficulty here? Let me know if you have any difficulties in this method.
No, sir.
Fine. We'll go with the third rule then. We'll go with the third rule. The third rule is trapezoidal rule. Have you studied this in engineering mathematics? Trapezoidal rule, Simpson's rule. Have you ever studied? Say yes or no.
No, sir.
Okay. Fine. So we'll go with this trapezoidal rule. The third one is trapezoidal rule. Okay. Assumption again it's same. For all the first three methods, your assumption is same. Your boundaries are joined by straight line. Here, what do we consider here is, we consider each segment as a trapezoidal. Okay. Note on the sketch, the same sketch. Note on this sketch. Okay. We consider each segment as a trapezoidal here. In trapezoidal rule, we consider each segment as a trapezoidal. It means my assumption again holds good. It holds good the same. Boundaries are joined by straight lines. Okay. Now I have strips. This is my strip, area of strip 1. This is my first strip. Let the area of the first strip be A1. Similarly, let the area of the second strip be A2. Similarly, let the area of the third strip be A3. Like this, I have nth strip, then the area of the nth strip will be AN. Okay? Area of the nth strip is AN. Any difficulties? Of course, again, in between I have A3, A4, A5, A6 up to AN. Okay? Now, what is A1 equals to? Area of the first strip. What is this? This is a trapezoidal. What's the area of a trapezoidal? What's the formula for area of a trapezoidal?
A plus B by 2 into H.
What is A plus B? What are they? What are those A and B in the sketch?
O0 and O1.
See, when it comes to trapezoidal, the area of a trapezoidal is it means average of parallel sides multiplied by the perpendicular distance. Okay, for the A1, for the A1, the parallel sides are O0 and O1. Okay, so average of parallel sides. It means O0 plus O1 by 2 multiplied by perpendicular distance. What is perpendicular distance here? Perpendicular distance between them.
D.
Okay, it is D. Now, can you tell me the formula for A2? Area of second strip.
O1 plus O2 by 2 into D.
Okay, O1 plus O2 by 2 into D. Okay, similarly A3.
O2 plus O3 by 2 into D.
O2 plus O3 by 2 into D. Like this. Area for nth strip. Area for nth strip.
O into N minus 1 plus ON by 2 into D.
On of minus On minus 1 plus On divided by 2 into D. Okay. These are the areas of the individual segments. These are the areas of the individual segments. But what I need ultimately, I need the total area A. So that is equals to, it is A1 plus A2 plus A3 up to AN. My total area is the sum of all the individual segments A1 plus A2 plus A3 up to AN. Okay? I think I will erase this sketch part here. Shall I erase this part?
Yes, sir.
Okay. So, the total area is A1 plus A2 plus A3 up to AN. Let us substitute those things. My A1 is O0 plus O1 by 2 into D plus my A2 is O1 plus O2 by 2 into D plus A3 is O2 plus O3 by 2 into D up to this happens to be On minus 1 plus On divided by 2 into D. Any difficulty in this? Any difficulty in this step?
No, sir.
Okay. Is something being common here? Yes?
D by 2, sir.
Right? Okay. So what I do is I'll take out D by 2. D by 2 is common in all the parameters there. Multiplied by it's O naught plus O1 plus O1 plus O2 plus O2 plus O3 up to On minus 1 plus On. Any difficulty in this step?
No, sir.
Okay. Can I further simplify this expression? Please check. What I do is I'll just remove the brackets, inside brackets. Right? Then what do I find? Just look at this. I have two O1s. Can you identify them in this expression? I have two O1s, isn't it?
Yes, sir.
Similarly, I have two O2s here,
Yes.
right? In the same way, I will have three O3s up to On minus 1. Sorry, in the same way, we will have two O3s. Okay? Then we will have 2 times of On minus 1. What are remaining here? In the sense now, these are all being paired.
Yes,
Okay?
sir.
ಅವೆಲ್ಲ ಪೇರ್ ಒಳಗವ ಇನ್ನು ಉಳಿದಿದ್ವು ಯಾವು
O naught and On.
ಅವನ್ ಪೇರ್ ಮಾಡ್ಬಿಡೋಣ ಅಂತ ಸೊ ಏನ್ ಮಾಡೋಣ ಐ ಹ್ಯಾವ್ ಓ ನಾಟ್ which is single. Okay, it's also ready to mingle with On now. O naught plus On. Those which are single, I have mingled them. Okay, O naught plus On. Any difficulty here? Plus 2 times of O1, 2 times of O2, 2 times of O3. This happens up to 2 times of On minus 1. Okay, can I further simplify this expression? Please check. Yes,
2 common, sir.
2 is being common, so I take 2 outside. It's O1 plus up to On minus 1. This is the formula for trapezoidal rule. You have to remember, either you try to derive the expression or you try to remember the formula. It's left to you. It's left to you. In what way you are going to, in what way you are going to follow this. Okay. This is trapezoidal rule or trapezoidal formula. Any difficulties in this derivation part?
No, sir.
Yes? No such difficulties?
No, sir.
Okay. Next, we'll go for the third rule, that is Simpson's 1/3 rule. Sorry, fourth rule. Third one is the trapezoidal, we just derived the expression. The fourth rule is Simpson's 1/3 rule. Can you see this portion? I'm writing Simpson's one-third rule here.
Visible, sir.
Visible? Fine. The assumption in the Simpson's rule is the short lengths of the boundary between the ordinates are parabolic arcs. We assume the boundaries joining the alternate offsets the variation of the boundary as parabolic. The assumption here is your boundary is going to vary as a parabolic nature between the alternate offsets. Okay, that's an assumption here. See, this exactly depicts the true nature of the topography. Generally, my topography will not be exactly a trapezoidal or it will not be a rectangle. You all agree for that. Okay, ಯಾವುದೋ ಒಂದು ಸಣ್ಣ ಪ್ಲಾಟ್ ರೆಸಿಡೆನ್ಷಿಯಲ್ ಬಿಲ್ಡಿಂಗ್ ಕಟ್ತಾ ಇದೀವಿ ಅಂತಂದ್ರೆ ಒಂದು ರೆಕ್ಟಾಂಗಲ್ ಅಥವಾ ಸ್ಕ್ವೇರ್ ಇರ್ಬೋದು. Or otherwise, if you just go to some area and you always look at the nature of the topography as irregular, which exactly depicts the parabolic nature. Again, not necessary that it has to be a parabolic. There are different curves also. Okay. Only thing is when the life becomes difficult, and in that case, engineer assumes something to make his life easy. So that's what we are doing here. We are assuming the variation of the boundary as parabolic. Okay, between the alternate offsets. This is important. It's between the alternate offsets. So we'll go with the derivation here. First, we'll derive the formula for the Simpson's one-third rule. Okay. I'll take first only 3 segments for the derivation. Later, we will use the same expression to, or we will expand the same formula for n number of segments. So what do I have is O0, O1, O2. The segment is of length D. The segment is of length D. This is first offset, second offset, third offset. And my assumption is my boundary is going to vary parabolic between alternate offsets. If this is my first offset, okay, next alternate is O2. Okay, O1, O0 and O1, they become consecutive. I'm not talking as a consecutive. The variation parabolic is being alternative like this. From O1 to O2. Two segments together, variation is parabolic. It is not for a single segment. Please remember. Assumption is for two segments. Considering two segments, the nature of variation of topography is parabolic. Okay? I think I'll just please note on this sketch and do one thing. You just write your equation in the chat box. I'll take this as that will be as an attendance. Okay, and this derivation again we will discuss in the next class. I'll stop it here. Please mention your equation in the chat box. Type your equation. Yeah, I don't find any equations here. Oh, good. Yeah, I could see 1, 2, 3, 4, 5, 6. Only 6 people have replied for this. Lateral entry. Okay, if you don't remember your question, lateral entry students can also type your name. Fine. Yeah, as of now, any difficulties for the today's class? The this module includes too many formulae.
No, sir.
Okay. Yeah, if you have given the attendance, fine, we will end the session. Thank you, one and all.